Chapter 2.5, we're going to be solving about 4 other types of equations. So we'll start with polynomial equations. So a polynomial equation is just going to be 2 polynomials essentially set equal to each other. So we say it's in general form if one side is 0 and the polynomial on the other side is in descending order in terms of the exponents. So for example, something like x cubed plus x squared minus 4x plus 3 equals 0. That would be a polynomial equation in general form. So typically the way we're going to be solving these is we're going to write these in general form if they're not already in general form. We're going to factor them and use that zero product principle from the previous sections. Okay, so let's do a couple examples. So we want to solve 3x to the 4th equals 27x squared. So something that might be tempting but you should never do, you never divide variables away. So we wouldn't be dividing both sides by, say, x squared here. So we're going to get this in general form first. So the way we're going to do that is subtract 27x squared to both sides. So that's going to give us 3x to the 4th minus 27x squared equals 0. We're left with 0 on the right, and we can't combine those because those are not like terms. And now we're going to factor it. So remember Gcf factoring, we have a Gcf of 3x squared. So when we factor that out front, we are left with x squared minus 9. So it's 3x squared times x squared minus 9 equals 0. And we can factor x squared minus 9. Difference of squares, we can factor that as x plus 3 times x minus 3. And now we use that zero product property, except this time we have 3 different factors, and we're going to set all 3 of them equal to 0. So we're going to set 3x squared equal to 0, x plus 3 equal to 0, and x minus 3 equal to 0. So solving all of these separately, this one on the left here, we would divide both sides by 3 and then take the square root. That would give us x equals 0. Second one, we would subtract 3. We get x equals negative 3. And then one on the right, we would add 3 to both sides and get x equals positive 3. So our solution set here would be x equals negative 3, 0, and positive 3. So we get 3 different answers here. Okay, so keep in mind that when we have a polynomial, we can get as many solutions as the highest degree of the polynomial, which is 4. So we could have gotten 4 answers here, we just happened to get 3. And there's a reason for that, which we won't get into right at this moment. So let's do another one here. So we have 2x cubed equals 2x squared plus 60x. So once again, let's get everything over here on the left. Always try to get the leading term to be positive. The leading term would be the x cubed term, so we'll get everything on that side. So we're going to subtract 2x squared to the left and subtract 60x. That's going to give us 2x cubed minus 2x minus 60x, and we're left with 0 on the right. So then we factor this. Once again, let's factor out this GCF of 2x in this case. So we factor out a 2x, and we're left with x squared minus x minus 30 equals 0. We can factor what's left over in those parentheses. 2 numbers that multiply to negative 30 that add to negative 1. That'll be x minus 6 times x plus 5. And now we have it factored completely, and we have to set each one of these factors equal to 0 separately. So that's 2x equals 0, or x minus 6 equals 0, or x plus 5 equals 0. And we solve all of these separately. For the one on the left, divide both sides by 2, we get x equals 0. The one in the middle, we add 6 to both sides, we get x equals 6. And the one on the right, we subtract 5 on both sides, we get x equals negative 5. Okay, so those are our answers here. So as usual, you could take these and plug them back into the original and for x, and then make sure that you get a true statement. For time's sake, I'll just leave it as this. Okay, so those are answers for that one. Next one, we'll do, I think do one more of these ones, and then we'll move on to the next type of equation. So x cubed plus x squared equals 4x plus 4. So let's get everything on the left. So it's going to be x cubed plus x squared. We have to subtract 4x and subtract 4 to the left. So minus 4x minus 4 equals 0. And this one, there is no GCF. This one we have to factor by grouping. So there's no GCF here, so we do it by grouping. So remember, we're going to group these two together. And we have to put a plus here because in the middle, because we can't just put a parenthesis after the negative, or technically that'll be changing the equation. Okay, so now we're going to do the GCF of both of these groups. So the GCF of the first one is x squared. We're left with x plus 1. The GCF of the second one, we can factor out a negative 4, and then we'll be left with x plus 1. And we factored out the negative 4 here on purpose because we wanted an x plus 1 left, so it matched that x plus 1. And now we can factor out that x plus 1. So when we factor out the x plus 1, we're left with x squared minus 4. We can factor the x squared minus 4. Difference of squares, x plus 2 times x minus 2 equals 0. And now we have these nice linear factors. We factored it as far as we could. And now we're going to set all of these equal to 0 separately. So we get x plus 1 equals 0. X plus 2 equals 0. Or x minus 2 equals 0. So for the one on the left, subtract 1, we get x equals negative 1. In the middle, subtract 2, x equals negative 2. And on the right, we add 2 and get x equals 2. So obviously I'm going through that part quickly because we should already know how to do this portion of it at the end. So we get the solution set negative 2, negative 1, and positive 2. Okay, so for polynomials here, get everything on one side and factor it as far as you can. Make sure you always try GCF first, and then recall how to factor a quadratic trinomial, difference of squares, and grouping. So those 4 main factoring methods. And then the zero product property. Okay, so the next type of equation is radical equations. So a radical equation is an equation where there's a variable in the radicand, meaning it's under the radical. So for example, something as simple as the square root of x equals 9. That would be a radical equation because we have an x in the radicand. So these steps for solving these, so I'm just going to say nth root because technically it can be any sort of root, but this is going to be the square root for now. So we're going to isolate the radical on one side of the equation and raise both sides to the nth power. That'll cancel the nth root. So if we have a square root, we're going to solve for the square root, and we're going to square both sides of the equation. That will cancel the square root on one side. And we will solve the resulting equation. If there's still radicals, we're going to repeat steps 1 and 2. So we do have to check our answers here. We have to check them because the domain of a radical is not all real numbers. So we have to make sure that we're going to check our answer back in the original, and we're going to omit any solutions that give us a false result. Okay, so let's do a couple examples. So just notice that I didn't check all of the ones from the polynomial ones because we did not have to do that, because the domain is all real numbers for polynomials. Okay, so we'll do this first one. We have the square root of x minus 1 equals 6. So first we isolate the radical. So we need to get that alone. So we need to add 1 to get rid of it on that side. So we get the absolute value of x equals 6 plus 1, which is 7. And then we need to square both sides. When we square both sides here, the squared and the square root cancel. So this is going to give us x on the left. X equals 7 squared, which is x equals 49. Okay, so to check this, just to make sure that it's correct, we have the square root of x minus 1. So I'm going to plug in 49 into x. And I'll put a little question mark because we're seeing if it's true. So square root of 49 is 7. 7 minus 1 equals 6. So this one is true. This one does check out. So that is our solution. If it didn't work, then we would have to omit that answer. Okay, so next one, 10 equals 5 minus radical x minus 1. Okay, so this time let's just get the 5 on the left. So let's subtract 5 because we need to isolate the radical x minus 1. So 10 minus 5 is 5. So we get 5 equals negative radical x plus 1. We still need to get rid of this negative, so we have to either multiply or divide both sides by negative 1. So 5 over negative 1 is negative 5, so negative 5 equals radical x plus 1. And now we're going to square both sides. So now let's square both sides so it cancels the square root and the squared. Negative 5 squared is going to be positive 25 equals x plus 1. We subtract 1 on both sides, we get x equals 24. Okay, so we're going to check this. So we're going to do 10 equals question mark 5 minus the square root of x minus 1. So plug in your answer, 24 minus 1. And simplify it. 5 minus 24 minus 1 is 23. Oh, whoops, I just realized I wrote this down wrong. So this was going back in here a little bit, this was a minus from the beginning. So it was x minus 1 right inside here. So let me just go back and fix all that. That's just going to change the last step. So minus 1, minus 1. We would have added 1 to both sides right here at the end instead of subtracted 1. And adding 1, we would have gotten 26. Okay, so it's an easy fix. So sorry about that. For checking this now, it's going to be 5 minus the square root of 26 minus 1. So that's going to give us the square root of 25. So that's going to give us 5 minus 5. So that gives us 0 on the right. That does not equal 10. So I'm going to put a little x. So we actually have to omit this. So we omit this value over here. And that means there are no solutions. Okay, so that time our answer did not check out. So there's no solutions. Okay, let's do 2 more. So the square root 2x minus 1 plus 2 equals x. So we have to isolate the square root. We have to isolate the square root of 2x minus 1. We have to subtract 2 on both sides. And we get the square root of 2x minus 1 equals x minus 2. And now we're going to square both sides. So squaring both sides here, I'm not going to write the squared. I'm just going to skip to the next step and put 2x minus 1 equals the other side squared. So just because it looks messy and hopefully you're comfortable with me skipping writing it. So it canceled the square root on the left, squares the other side. And now we have to solve this resulting equation. So this is a quadratic, right? We're going to have to expand the right-hand side. So x minus 2 squared is x minus 2 times x minus 2. That's going to give us x squared minus 4x plus 4. So hopefully we're comfortable solving these by now. And let's get everything on one side and get it set equal to 0. So I'm going to subtract the 2x and I'm going to add 1 to both sides to get them to the right-hand side. The reason is because I want to keep the first term x squared positive. So getting everything on the right, negative 4x minus 2x is negative 6x. 4 plus 1, we get 5. So now we have this quadratic, 0 equals x squared minus 6x plus 5, and we solve this by factoring. We can factor this as x minus 5 times x minus 1, and now we do the zero product property and say either x minus 5 equals 0 or x minus 1 equals 0. So on the left-hand side we add 5, right-hand side we add 1, and we get x equals 5 and x equals 1. So now we have to check both of these in the original. Put this up here. So let's check. So we're going to plug in the 5. So 2 times 5 minus 1. So plugging this into the original equals 5. Put a question mark. And simplify this. So under the radical we have 2 times 5, which is 10, minus 1, which is 9. So radical 9 plus 2 equals 5. That gives us 3 plus 2 equals 5, which is true because we end up getting 5 equals 5. So we know that 5 is a solution, so 5 works. And now let's check it for x equals 1. So plugging in a 1 into the original, it's going to be radical 2 times 1 minus 1 plus 2 equals, with a question mark, 1. And simplifying this, under the radical we get 2 minus 1, which is 1. So radical 1 plus 2 equals 1, which gives us 1 plus 2 equals 1, which we get 3 equals 1, which obviously is not true. So we have to omit the x equals 1. So our only answer here, I'll write this in set notation, is just x equals 5. Okay, so now for one more for this one. We have the square root of 3x plus 1 minus the square root of x plus 4 equals 1. So notice that this one we have two different square roots this time. So we have to choose which one we want to solve for, and then we can do the same thing we just did. So let's solve for this one on the left, which means we have to add the square root of x plus 4 to both sides of the equation here to cancel it right there. And that's going to give us the square root of 3x plus 1 equals the square root of x plus 4 plus 1 on the right. So now, just like we did before, we have to square both sides. So we're going to square this side and we're going to square this whole side. So the square root and the square are going to cancel, and we're going to be left with 3x plus 1 equals the square root of x plus 4 plus 1 squared. And now we have to FOIL out that right-hand side. So I'm just going to write two of them next to each other since it's being squared. So it's that times itself. And now we are going to have to FOIL that right side out. So it's pretty messy, but it's pretty doable. So the square root of x plus 4 times the square root of x plus 4, the square root is going to cancel, and we're just going to be left with x plus 4. So that was that times that. Now we have to do the square root of x plus 4 times 1, which is just plus the square root of x plus 4. And now we have to distribute the 1. So 1 times the square root of x plus 4 is the square root of x plus 4. And then 1 times 1, we get plus 1. So I'm going to combine these two middle terms. These are the same thing, right? So one of those plus another one will give us two of them. So I'm just going to erase all of this and combine those in this step. So it's going to be plus 2 square root of x plus 4 plus 1. And now it's just like the equations that we've already done. We have one square root here. So let's isolate this and let's square both sides. So I'm going to subtract x on both sides. So this x right here I'll subtract. And then we will get 2x plus 1. And let's combine this 4 and the 1. So it's 5 plus 2 square root x plus 4. And now we need to subtract the 5 on both sides. So it's going to be 1 minus 5. So 2x minus 4 equals 2 times the square root x plus 4. So almost done. Now we have to divide both sides by that 2. So divide by 2. So we divide both of those terms by 2. 2x divided by 2 equals 2. 2x divided by 2 equals x. And 4 divided by 2 equals 2. So it's x minus 2 equals the square root of x plus 4. So this looks a little bit cleaner now compared to what it looked like up here. And we have to square both sides now. So it's going to cancel with the square root over here. And we're going to get x minus 2 squared equals x plus 4. And now we have a quadratic. So now this left-hand side, we're going to FOIL that out. We get x squared minus 4x plus 4 equals x plus 4. Subtract x on both sides, subtract 4 on both sides. Negative 4x minus x is negative 5x. 4 minus 4. The 4's actually cancel, so we get x squared minus 5x equals 0. And now we can factor out an x, and we're left with x minus 5. We solve these separately, set them both equal to 0. We get x equals 0 and x minus 5 equals 0. For the one on the right, we have to add 5 to both sides. So we get x equals 0 and x equals 5. So super messy. But now we have to check these in the original. So let's check. I'll do it down here a little bit. Let's check this for x equals 0 first. So we have to plug in a 0 into the original, this original one. So it's the square root of 3 times 0 plus 1 minus the square root of 0 plus 4. And we want to see if this equals 1. So simplifying this, go a little bit faster for this part. Under that first square root, 3 times 0 is 0. 0 plus 1 is 1. Square root of 1 is 1. For the second one, square root of 4 is 2. So we get 1 minus 2, which is negative 1. So that does not work out. Negative 1 does not equal 1. So we have to omit x equals 0. And now checking it for x equals 5. So same thing, we plug it in. 3 times 5 plus 1 under that square root minus 5 plus 4 equals question mark 1. And we simplify it. First one, we get 15 plus 1 is 16. Square root of 16 is 4. Second one, we get square root of 9, which is 3. We get 4 minus 3, which is 1. So that one actually works out. So we only get one answer here, and it is x equals 5. Okay, so obviously that one is pretty long, but let's move on to the next thing now with rational exponents. Okay, so recall that expressions with radicals, all they are, they represent rational exponents. Like the square root of x is x to the 1/2 power, but we can have other roots as well. We can have any number. So if we have the nth root of a to the m power, we can rewrite that as the nth root of a and then raised up to the m power. or we can write it as a raised up to the m over n as a fraction, as a rational exponent. So for example, we could have something like the fourth root, I'm write that a little bit closer to that radical, the fourth root of x cubed. We could write that as the fourth root of x and then cubed. This is all the same thing as x to the 3/4 power. So those all mean the same exact thing. So in my opinion, what I like better is I like working with it like this last one as a exponent. I think it's a little bit more clear about how to solve them. So here are the steps to solving them. So if we have an equation with a rational exponent, so we have x to the m over n equals k, m, n, and k are numbers here. What you're going to do first is you're going to isolate the expression, the variable with the rational exponent on it. So you're going to solve for x to the m over n, and then you're going to raise both sides to the n over m. So you raise both sides to the reciprocal power. So since you're raising something that's already raised to a power, to another power, power to a power, you multiply. When you multiply reciprocals, they equal 1, so they cancel each other out. So that's how you cancel out an exponent, by raising it to its reciprocal exponent. Okay, so there is one thing you have to watch out for. If m is even, so if the original numerator is even, so that m right here, then that means you're going to get plus or minus as your answer. So I'll put a little note. You'll get a plus or minus. That's like x squared equals 4. You take the square root of both sides, you get plus or minus 2. Same concept. If m is odd, so now if this original numerator and the exponent's odd, you only get a plus. You don't get a plus or minus. Okay, and then you can check all solutions in the original again. So let's do a couple examples, because that probably doesn't make too much sense with just examples here. So let's solve the equations here with rational exponents. So we have 3 times x to the 3/4 minus 6 equals 0. So we have to isolate this variable raised to that power. So first we have to add 6 to both sides. So we get 3x to the 3/4 equals 6. Divide both sides by 3. We get x to the 3/4 equals 2. And now we're going to raise both sides to the 4/3 power. So raising this side to the 4/3 will cancel that exponent, which is our whole point of doing that. So before we even do that, let's take a look at this right here. The numerator in the exponent is odd. So we're only going to get a positive answer here. We're not going to get plus or minus. So raising both sides to the 4/3 will give us x equals 2 to the 4/3. So technically this is one acceptable answer. Another acceptable answer here would be, so I'll put or, would be 2 to the 4th to the 1/3, not cubed, to the 1/3. So what you would try to do first here is use that root to help you simplify it, but 2 to the 1/3 power isn't anything nice, so let's raise it to the 4th. So this is going to be 2 to the 4th is 16, so this would be 16 to the 1/3. Okay, so that's going to be x equals 16 to the 1/3, or I'll put it up here. I'll just leave my answer like that, so it's I already have too much going on here. So 16 to the 1/3 power. So whatever the cube root of 16 is, not a super nice number. It'd be something 2 point something. You could also write it, which I'll just write it up here, or the cube root of 16. So there's so many different ways you can write this. I personally like it as 16 to the 1/3 power because it can't be simplified anymore, and I like the exponents better. Okay, so all of that for just that little answer there. So let's do one more, well, two more, I guess. So two more here. So we have x to the 2/3 minus 3/4 equals -1/2. So we have to isolate the x to the 2/3 by adding 3/4 to both sides. So adding 3/4 is going to cancel it over here, and we're going to get x to the 2/3 -1/2 plus 3/4 is going to be 1/4. You have to get common denominators. And now we're going to raise both sides to the reciprocal of 2/3, which is 3/2. Okay, and then it's also important to note that this numerator in the exponent is even. So that's going to give us a plus or minus answer. So raising both sides to the 3/2, it's going to cancel x to the 2/3. It's going to be left with an x. And we're going to have plus or minus as an answer. 1/4 to the 3/2 power. 3/2 power. And now we can simplify this a little bit. So it looks pretty messy, but it's really not too awful. So let's take the square root first. So it's going to be plus or minus 1/2 or 1/4 to the 1/2 and then cubed. So all I'm doing here is using the property of exponents and saying let's take the square root before we cube it. And the reason is because now it's a little bit, we can simplify it. 1/4 to the 1/2 is the square root of 1/4, which is going to be 1/2. So now we just have to do 1/2 cubed, which is 1/2 times 1/2 times 1/2. Or we can cube the numerator, cube the denominator separately. Either way, we get 1/8. So just writing this as a solution set, that would be -1/8 and +1/8. So it looks pretty messy because I'm writing down almost every single step here, which you don't have to write down every single step. You can maybe skip a step or two without showing it. But you also, I'll leave it for you guys just because I don't have any room. You could check your answers by plugging them in the original. Obviously, it's a lot more annoying with these fractions though. So let's do one more. So we have x minus 1 to the 1/3 minus 6 equals -2. Okay, so we have to actually isolate this whole thing first. That whole thing is raised to the 1/3 this time. So we have to add 6 to both sides. And we get x minus 1 to the 1/3 equals -2 plus 6, +4. And we have to raise both sides to the reciprocal of 1/3, which is 3. Okay, so we can be fancy. Instead of saying raise both sides of the 3rd power, we can say let's cube both sides. And let's recognize right before we do it, this numerator of 1 is odd, so we're only going to get a positive answer, not plus or minus. So raising both sides to the 3rd power is going to cancel the 1/3 on the left. So it's going to be x minus 1 equals 4 to the 3rd. That's x minus 1. 4 to the 3rd is 64. X minus 1 equals 64. We add 1 to both sides and get x equals 65. Okay, so that one is actually pretty nice. Let me just write it in a solution set. So this one would be pretty easy to check. You just have to plug in the 65 with no fractions, and it'd be pretty simple. Okay, so moving on to the next thing. So equations that are in quadratic form. So I'll just do one example of this. So some equations may not be quadratic equations. They may not be degree 2 polynomials, but they can be written and solved as if they were quadratic equations. So for example, let's say we had x to the fourth minus 10x squared plus 9 equals 0. So clearly not a quadratic equation, right? Because this exponent is a 4, so that would be a degree 4 polynomial, not a quadratic. However, we could think of this as a quadratic because we could write this as, instead of x to the fourth, we can write it as x squared squared minus 10x squared plus 9 equals 0. So technically this is in quadratic form because it's something squared plus or minus that same something plus or minus a constant. So you can think of that x squared as like a different variable, like a u, and it would be u squared minus 10u plus 9 equals 0, which would be a quadratic. Okay, so let's see an example of this. So like I mentioned, we can solve this the same way that we solve quadratics, hopefully factoring or quadratic formula. So let's solve x to the fourth minus 8x squared minus 9 equals 0. So we have a degree 4 polynomial, and we cannot factor, well, we can't factor it using a GCF like we might want to. So let's rewrite this as x squared minus 8x squared minus x squared squared for that first one minus 8x squared minus 9 equals 0. So something I'm going to do here, you don't have to do it, but it might help you factor it. If we I mentioned it when I wrote the above example, let x squared equal another variable, so I'm just going to use u. You don't have to, I'm only doing this to help factor if you need help factoring. So instead of x squared, we're going to have u, so it's u squared minus 8 times u minus 9 equals 0. And now let's use that to help us factor it. It's going to be u, so we can now probably see how it's quadratic form, so we can factor like we usually do. U plus or minus something times u plus or minus something equals 0. Two numbers that multiply to negative 9 that add to negative 8 would be negative 9 positive 1. So u minus 9 times u plus 1. And now we can plug back in for x squared. So instead of u, let's use x squared again. Because we factored it, so we don't need to use the u anymore. We only use the u to help us factor it. And now we have x squared minus 9 times x squared plus 1. We can factor x squared minus 9 as x plus 3 times x minus 3. We cannot factor x squared plus 1. X squared plus 1 is not a difference of squares because of the addition, it's not subtraction. So now we can take all of these, set them equal to 0, x plus 3 equals 0, x minus 3 equals 0, x squared plus 1 equals 0. First one, we have to subtract 3 on both sides. We get x equals negative 3. Second one, we add 3, get x equals 3. The one on the right, if we subtract 1, we get x squared equals negative 1. And then we would take the square root of both sides on the right. We would get x equals plus or minus the square root of negative 1. The square root of negative 1, that is not a real number, that's an imaginary number, and that's actually the definition of the imaginary unit I. So we have to remember back to the imaginary unit section. So we get technically 4 different answers here. We get x equals negative I, positive I, negative 3, and positive 3. Okay, so another pretty messy one, but this is in quadratic form. Even though it's not a quadratic, we can solve it the same way that we solve quadratics by using this method. Okay, so for the last thing now, we have equations involving absolute value. So the absolute value of x, which is denoted with the vertical lines, the absolute value of x with the vertical lines, it represents the distance of x from 0 on the number line. So let's say we have this pretty basic equation, the absolute value of x equals 2, and we're just trying to solve that for x. So what values of x would make this statement true? So clearly 2 would work, positive 2, because it's a distance of 2 away from 0 on the number line. But negative 2 would also work because negative 2 is 2 units away from 0 also. So the two solutions for this are negative 2 and positive 2. So in general, what we're going to be doing here is we're going to be isolating the absolute value. And when we isolate the absolute value, we'll end up with the absolute value of something. So the variables in the absolute value. So the absolute value of some expression f of x equals k, where k is a number. If the k is a positive real number, then we're going to have two separate equations we have to solve. We're going to drop the absolute value bars and set it equal to k. We're going to drop the absolute value bars and set it equal to negative k. Just like we did up here, we said, okay, the absolute value of x equals 2. Drop the absolute value bars, it equals positive 2. Drop the absolute value bars, it equals negative 2, which were our answers. Okay, so we're doing the exact same thing, except we might just have an expression other than just x this time. If the k value is negative, if we have the absolute value of x equals a negative number, there's no solutions because the absolute value of a number can never be negative. Okay, so let's see how we do this with a couple examples. So we have the absolute value of x plus 3 equals 10. So we already have this isolated. We already have the absolute value isolated, so all we have to do is split this up. We drop the absolute value bars and let it equal the positive version, and we drop the absolute value bars, I'll put an or actually. So, and then we drop the absolute value bars and set it equal to the negative version. Okay, so now we have these two linear equations that we solve. So the one on the left, subtract 3, we get x equals 7. And the one on the right, we subtract 3 and get negative 10 minus 3, x equals negative 13. So let's actually check these. I'm not going to check all of them, but I'll check these ones just so we can see how this works. So I'll put this right over here. Let's check it for x equals negative 13. So we're going to plug this into the original. Negative 13 plus 3 equals 10. I'm going to put a question mark because we're checking. So we get the absolute value of negative 10 equals 10, which is true because the absolute value of negative 10 equals positive 10. So that one works. And let's check this for x equals 7. So plugging in a 7 into the original, 7 plus 3, the absolute value of 7 plus 3 equals 10, question mark, that's the absolute value of 10 equals 10, which is true. We get 10 equals 10. Okay, so most of the time for these ones, we're going to get two answers. Technically, we don't have to, but a lot of the time we will. So as a solution set, we have x equals negative 13 and x equals 7. Let's do about two more here. So we have 5 times the absolute value of 1 minus 4x minus 15 equals 0. So first we have to isolate the absolute value. So we have to add 15 to both sides. So we add 15 to the right-hand side, and we get 5 times the absolute value of 1 minus 4x equals 15. And now we divide both sides by the 5, so we have to completely isolate that absolute value. So we get the absolute value of 1 minus 4x equals 3. So now that we have it isolated, we're going to solve two separate ones. We're going to drop the absolute value bars, let it equal positive 3, and then we're going to drop the absolute value bars and let it equal negative 3. So solving these both separately, we can subtract 1 on both sides for on the left. Subtracting 1 will give us negative 4x. 3 minus 1, we get 2. Divide both sides by negative 4, we get x equals 2 over negative 4, which is x equals negative 1/2. For the one on the right, we can subtract 1 on both sides, we get negative 4x. Negative 3 minus 1, we get negative 4. Divide both sides by negative 4, we get x equals negative 4 over negative 4, which is x equals 1. So once again, you could check these if you want. We get two solutions, x equals negative 1/2 and x equals positive 1. Okay, so let's do one more here. We have 0 equals 4 times the absolute value of 6x plus 15 plus 20. So let's isolate the absolute value. We have to subtract 20 on both sides. So we get negative 20 equals 4 times the absolute value of 6x plus 15. So the absolute value here is on the right side of the equation. It does not matter at all. It's the same exact thing. And we have to divide both sides by 4 to cancel that 4. So we end up getting negative 20 over 4, which is negative 5, equals the absolute value of 6x plus 15. Okay, so you have to be careful here. We're not going to chop this up and do two separate things. This, we have the absolute value equals a negative number. That means there's going to be no solutions because the absolute value will never be negative. Okay, so that's just something you have to recognize and make sure that you don't keep on trying to solve it, because you will get values if you solve it and it will be incorrect. Okay, so that's it for this section. We solved polynomial equations, we solved square root equations, rational exponent equations, and absolute value equations.